Welcome to the Rocket Warhead Demating Machine, also known as RWDM. In collaboration with the Bluegrass Chemical Agent Destruction Pilot Plant, the Program Executive Office, Assembled Chemical Weapons Alternatives, the United States Department of Defense, Amentum, CRG Automation, and others, we have come together as one team with one mission, our final mission. To begin operation, the system must be preloaded with 3 Rocket Warhead Containerization System skids, 2 rocket mortar crates, 2 upper shipping and firing tube containers, and 15 M55 rockets. One skid will have 25 empty canisters, the second skid, 5 empty canisters, and the final skid completely empty. The RWCS stations will have magnetic pullers and pneumatic pushers to locate the skids consistently for robot operation. 4 pallets of M55 rockets will be brought into the unpack area to begin the process. This will allow a total of 60 rockets to be processed. The forklift operator places an M55 rocket pallet on the adjustable height unloading table. The operator will then mark the shipping and firing tubes, or SFTs, at the 12 o'clock position to maintain storage orientation. 2 operators will then load the rocket non-destructive examination input carousel cradle. Utilizing 2 sets of indexing control stations, one on each end of the carousel, each operator will press the button on their end to index the carousel to the next open position. The operators will then repeat this process until 15 shipping and firing tubes are placed in the carousel. Once the input carousel has been loaded and the unpack area operators have left the room, the control room operator can start the scanning process via the Human Machine Interface, or HMI. Once the HMI commands have been given, the 2-axis robot will pick up a shipping and firing tube from the carousel and place it into the X-ray cabinet and close the top door. The X-ray motion sled translates over to the scanning zone and tilts the SFT 10 degrees down to allow for easier liquid detection in the M56 warhead. Once the X-ray scan is complete, a trained operator will be presented with an image of the results to interpret on the HMI. Based on the operator's assessment, an accept, retry scan, or reject designation will be manually input into the HMI. All image acquisition and reviews will be done in the image review and disposition system in the control room. The shipping and firing tube will then be conveyed from the rocket non-destructive examination system into the Alpha airlock. The rocket material handling gate nearest to the unpack area will then close. The rocket material handling airlock gate nearest to the process area will then open to allow the conveyor to move the shipping and firing tube from the Alpha airlock into the process area. The shipping and firing tube will then be conveyed to the end of the conveyor. The last section of conveyor is mounted to the horizontal slides that will traverse the conveyor section into the rocket handling robot's reach area. From here, the SFT will be placed into the vertical rocket cutting machine, which is the same design as those currently in use in the main plant. Once the SFT has been loaded and is securely held by the lower clamp, the cutter assembly will engage and the cutter wheel and back rollers will be driven inward to the start cut position. The cutter assembly rotates 370 degrees, alternating back and forward bidirectionally around the statically held shipping and firing tube. The top half of the shipping and firing tube is then removed and placed on the transfer station. The robot then grips the exposed warhead with the end of arm tool, and the rotating cutoff tool separates the warhead from the rocket motor. The robot will then move the upper shipping and firing tube from the transfer station and place it into the upper shipping and firing tube container. The robot will then pick up any empty canister from the canister transfer and weigh station and place it into the crimp station. The crimp station will lower the canister, and the lower gripper on the crimp station will securely grip and hold the canister. The robot will then remove the top cap from the canister and place it onto the canister cap holding station. The robot will then pick up the cut warhead from the warhead and shipping and firing tube transfer station and place it into the canister. Then the robot will pick the top cap from the canister cap holding station and place it back into the canister containing the cut warhead. The canister will then be crimped. After crimping, the crimp station will raise the canister up to be picked by the robot. The robot will then place the canister onto the scale of the canister transfer and weigh station. The weight of the canister will be recorded by the historian. After the weight is recorded, the robot will remove the canister and place it into an empty opening on the RWCS skid. This will repeat until 15 rockets have been processed. Then, a brief entry into the unpack area to support reloading the rocket non-destructive examination carousel with 15 more shipping and firing tubes. Once 30 rockets have been processed, a full changeover of all skids and containers will happen. CRG Automation is humbled to have worked with such an incredible and collaborative team over the last 4 years. Congratulations to all who have been involved. Mission complete.